Hey guys, welcome back to my channel. In this video, we'll be covering all the concepts of the chapter circle. So this is a chapter for your class 11 HSC part 1. This is chapter 6. So circle, as we all know, is a very basic shape that we have been studying since we were kids, right? You see circle everywhere, be it how you start drawing planets, the everyday food you eat, every basic thing you see, right? Even a face, the basic shape is a circle. Everybody who draw, doodle, everything, right? So everything revolves around circles. So they are a very important thing to study about. And also in architecture, right? Many beautiful things that you see use some or the other form of circle, right? They have curves and bends, and if somebody is making a sculpture, right, there have to be some curves, right? A human body, it has so many different ways that a person is shaped. So every field in one way or the other requires circles. So we'll be studying circles in this chapter. We'll be doing all the concepts in this chapter, and solutions for the questions and everything will be given in the successive videos. So let's start. For the first exercise, you need to know the different forms of writing the equation of a circle. So there are three forms of writing the equation: standard form, center radius form, and diameter form. Okay, so we'll start with the standard form. In standard form, what you require to know is that how do you write this equation. Okay, so if this is your circle, the center of the circle lies at the origin, okay, which is at 0 comma 0, and the radius is r. How do we know that? This point on the circle is at the location r comma 0. R comma 0 means on the x-axis at the point r, or the number r. So 5 comma 0 means 5 units from the origin. So r comma 0 means r units from the origin. Hence the radius is r over here. So how do you write this in standard form? In standard form, you will write this equation as x square plus y square is equal to r square. Okay, this is the equation. X square and y square are variables. In r square, you might know the value of the radius of your circle, or you might not know the radius. Okay, while you're solving questions, you might be given some hints like this point lies on the circle, the center is over here, or you might be given the radius is this point lies on the circle, find the center of the circle. So they can give you any sort of question. These are some things you need to remember. So multiple concepts are added, mushed together, and then you're asked to solve a particular question. We're done with one form, that is the standard form. Let's move on to the center radius form. What is the center radius form? In center radius form, your center is not the origin. Your center over here, for example, is h comma k. Alright, and let this be your point x1 comma y1. Again, the radius is r. So the distance between h comma k and x1 y1 is r. Okay, r is a notation we are going to be using for radius in this chapter. Again, it might change from chapter to chapter or place to place, subject to subject as well. So don't think of r as radius everywhere you see. Sometimes it might become something else. So now in this chapter, for this subject, r is your radius. Small r signifies radius. So what will be the center radius form? In center radius form, you will be writing x minus h. That means an unknown variable minus the x intercept of your center, the whole square, plus y minus k, the whole square, is equal to r square. Okay, now you might think of this as the distance formula basically. This radius r is equal to the under root of x minus h1 the whole square plus y minus k the whole square. Okay, so x1 minus h the whole square plus y1 minus k the whole square is equal to r square. How do you get r? The distance formula. Okay, moving on to the diameter form. Now we might all have studied as kids in lower classes that the diameter of a circle projects a right angle at any one of its sides. So an angle inside a semicircle with one side as the diameter is always a right angle, right? So this is your center. I'll not be explaining the concept behind this because derivating it and all, it's not that important. What you need to know is how to write it. Suppose this point of the diameter is x1 comma y1. Okay, and suppose this point is x2 comma y2. Alright, and this is your origin. Let's suppose 0 comma 0. It's not compulsory that it's 0 comma 0. We're considering 0 comma 0 here. This does not affect anything. So let's see. In diameter form, instead of having x square and y square, what you have is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. No radius square, nothing is equal to 0. That's it. Okay. Now that we're done with these three things, you can now essentially solve exercise 6.1. Let's move on to your exercise 6.2 part. In exercise 6.2 part, all you need to know is the general equation of this circle. Alright, so this is the general equation of a circle. X square plus y square plus 2gx plus 2fy plus c is equal to 0. Now g, f and c will be constants. So your only unknown variables are x and y over here. So how do you find the radius of this circle? Now you see this condition over here only if g square plus f square minus c is greater than or equal to 0. Right? So the radius of your circle determined by this general equation is under root g square plus f square minus c. Okay. So it is g square plus f square minus c is equal to r, or radius. Now how do you find the center? Center of a circle is minus g comma minus f. That's it. That's all you have to remember. So what is the radius? G square plus f square minus c, the whole under root. The center is minus g comma minus f. That's all. Now you can also solve your exercise 6.2. Though you might have to use some other brains, like they'll give you the radius is this, c is this, f is this, find g. Or they'll give you center is this is your coefficient of c, find radius. Okay, they can give you such manipulative questions wherein the different parts of this formula are given. You'll have to just substitute the given part and find the answer. Now moving on to tangents. Tangents is a very important part of this chapter. So what are tangents? Tangent is basically a line that just touches your circle. It does not pass through like this, that will make it a secant. It does not just pass undeviated, that means it does not pass from far away. Okay, that will just be a line. So what it does is it essentially touches your circle at one point, right? So at this point you can see that this tangent here is touching your circle. Alright, don't forget to draw these two arrows over here, since tangent is a line, not a line segment. And this is the center of your circle. Alright, and this is 90 degrees. So this is the radius of your circle, this is the tangent. We all know that the radius and the tangent are perpendicular to each other. Okay, so now what is the equation of tangent of a circle? The equation of a tangent of a circle is x1 plus y1 is equal to r square. Okay, you can do the derivation. If you need the derivation, comment down below. I'll be giving you the derivations as well. But right now, this is all the information that you need to solve the given questions. Okay, and what are x1 and y1? x1 and y1 are the points on the circle at which the tangent is drawn. So x1 and y1 are essentially this point. Okay, so this point is x1 comma y1. All right. Now there is another form of writing your tangent, and that is parametric form. Okay, parametric form means the circle is also written in a parametric form. Okay, wherein you the point in a circle is determined by using the angle, and based on that angle you can find a point. So if the angle is given to be 30 degrees, you'll take a point 30 degrees from this. The distance will be r. Okay, and you'll have the center point, and you'll find this point with respect to that. Now similarly, the parametric form of a circle is x cos theta 1 plus y sin theta 1 is equal to r. Alright. Now moving on. For tangents drawn from a point outside the circle onto the circle. So for example, you are given that there is a circle. There is a point, say x1 comma y1, and they draw two tangents. Now from any point external to the circle, you can draw at most two tangents. Okay, so this is one tangent here, this is another tangent here. All right, so these are two tangents which are drawn from the circle. Now they might ask you, tell me the equation of this circle. You know the point that lies on these lines. Okay, sorry, they might ask you the equation of these tangents with respect to the circle and this point. So you know this one point. Suppose you don't know this point or this point, right? You don't know the point at which they are touching a circle. You only know one external point from which both your tangents are originating. How will you find the lines? There is a relation for your slopes of the tangents. So let the slopes of the tangents be m1 and m2. So the slope of this tangent is m1, the slope of this tangent here is m2, for example. So how will you find m1 and m2? m1 plus m2 is given by 2x1y1 upon x1 square minus a square. Okay, and m1 into m2 is given by y1 square minus a square upon x1 square minus a square. Okay, if you remember these two parts, all right, this and this, you can easily find your m1 and m2. If this line is given, this point, sorry, x1 comma y1 is given, you can find these m1 and m2 easily. Then you can use m1 plus m2 the whole square formula and find your m1 and m2 from there. Now know this, if your circle is given and you have a point A inside the circle, a point B on the circle and a point C outside the circle. From this point A, you can draw 0 tangents. Why? If you draw a line from inside the circle, there is no way that it touches your circle only once. Okay. If you draw a line anyway on the circle, it will intersect with your circle twice. And that will make your line a secant. Now, if you're given a point B on the circle, meaning on the circumference, you can draw at most one tangent. So, if a point is given, only one line can be made from it that just touches it. Because if you shift the angle by even 0.02 or 0.0001 degrees, the circle touches it at 2 points, essentially becoming a secant. If you're given a point C outside the circle, you can draw two tangents. So from a point B on the circle, you can draw one tangent. And from a point C outside the circle, you can draw two tangents. Remember this? Okay, and they might ask you a question like, for a circle so and so, there is a point, they'll give you a random point and they'll ask you how many tangents can be drawn from this point, and you will just check if that point lies inside the circle, outside the circle, or on the circle. How will you do that? Now if you are given this, right, there is this general equation of your circle. Suppose this is your general equation, you're given values. Okay, suppose you're given x square plus y square plus 8x plus 6y plus 3 is equal to 0. And you're given a point 2 comma 2. For example, okay, even I don't know if it lies on the circle, outside the circle, or what. So how will we solve this? We will solve this by taking it as a point. Okay, so what we'll do is, now we will essentially substitute 2 and 2 in place of x and y. So we'll substitute 2 square plus 2 square plus 8 into 2 plus 6 into 2 plus 3. What does it give you on simplification? It gives you 4 plus 4 plus 16 plus 12 plus 3. What do you get from this? You get 20, 36, 39 is equal to 39, which is greater than equal to 0. Since it is greater than equal to 0, you will get that this point is outside the circle. If it is exactly equal to 0, the point lies on the circle. Okay, so if let's say that the equation of the circle is symbolized by C. Okay, so C x1 y1, if it is greater than equal to 0, the point lies outside. What do I mean by C x1 y1? It means that in the equation of C, instead of x and y, the variables, you will be substituting the point given to you x1 y1. If it is greater than equal to 0, that is, on substituting, if you get the number greater than, or sorry, if you get the number just greater than 0, right, then you will say that the point is outside the circle. On substituting, if you get it to be equal to 0, then the point is on the circle. And now if you get the point to be less than 0, that means the point is inside the circle. So in this case there will be no tangent, this case one tangent, and in this case two tangents. Okay, and this is not just to find out how many tangents. There will be more uses of this. They might also ask you one very simple question in MCQs or something ki this point, does it lie inside, outside, or on the circle? Okay, 2 mark ke liye you are asked this question, and that's it. You just have to substitute, see if the number is greater than, equal to, or less than 0, and then write your answer. Done with this, one more exercise done. Okay, now moving on to director circle. What is a director circle? Now, if you have the tangents that are forming a 90 degrees, okay, so let's say there are two tangents, this and let's say this. All right, they intersect at a point and they form 90 degrees. Okay, and when you draw so many more such pairs of tangents that form 90 degrees, you realize that the points of intersections of these tangents forms a circle, right? And this circle formed by the point of intersection of these pair of tangents that form a 90 degrees is called a director circle. And what is the equation of a director circle? The equation of a director circle is given by x square plus y square is equal to 2r. Okay, so basically the 2r square. So basically the radius of your director circle is root 2r. Radius of director circle is equal to root 2r. I'll write that neatly for you guys, so you can just take a screenshot of director circles. If you want, I'll also be putting the PDF. Okay, just comment down below if you need the PDF, and I'll be sure to upload this in the comments or in the description. Okay, so radius of director circle is equal to root 2r. Hence, on squaring it, you get 2r square. All right, this was whatever you needed. There is this part in extra information, okay, wherein they're saying that in different cases that a circle interact with each other, you can form a relation between the distance between the center of the two circles and their radii. Okay, now for example, in this case, when the two circles are just touching each other, let the radius of this circle be r1, radius of this circle be r2. The distance between centers is equal to r1 plus r2. Alright, now in this case, wherein one circle is inside the other circle, we'll take this. Sorry, the distance between the centers is equal to r1 minus r2. You can take a mod, so no matter which one you take first, I am taking this as r1 and this is r2. Even if you take the other way around, if you put a mod, you're sorted. Alright, moving on, there is this circle. Okay, now they're not even touching. Suppose this one is r1 and this one is r2. So the distance is greater than r1 plus r2. Alright. And in this case, wherein the circles are intersecting at 2 points. Okay. So these circles, they are touching each other. Suppose this is the centers. This is r1 and this is r2. This is not equal to r1 plus r2, neither it is as small as r1 minus r2. Alright, so this D lies between r1 minus r2 and r1 plus r2. Alright, so I have explained these in short. There is not many questions asked from this. They might ask you an MCQ, or they might ask you a 1-marker question or a 2-marker question max to determine the distance between two circles if the radii are given, or if the distance is given and they can ask you to find radius of one of the circles by giving another circle's radius. Okay, nothing too deep will be asked. Okay, you might be asked general knowledge questions, like I said, in MCQ. Not a very important topic, but you should study it since it's given in your book. So guys, that's all the concepts of circles covered in less than 20 minutes. Okay, so if you have any doubt, comment down below. I have only covered the formulae, okay, whatever you will be needing to solve the given question. If you want the derivation of any of these things, comment down below. I'll be sure to make a video on that. I'll give you all the derivations you need, because in the exam, if a concept doesn't click or if a formula doesn't click on the spot, you should be able to derive it on your own. Okay, and maths is a subject where everything is interrelated. So if you know even basics, you can solve most complex questions, because be it math, be it physics, be it chemistry, or any science subject, every complex question is derived from a basic concept. Okay, so if you know the basic concepts, you'll be able to solve it. So make sure your basics are strong, and no problem if you have any doubts in any basic concepts as well. Okay, comment down below whichever topic you want, whichever chapter you want. Okay, don't hesitate. Even if it's from grade 5, I'll be surely taking basic lectures on those videos as well. So guys, thanks for watching. Don't forget to like, share, subscribe, comment down below, and do share it with the friends who need this. Okay, from the next video onwards, we'll be solving the questions of this chapter.